Hello and welcome to Lesson 7E, Solving Equations with Fractions. So to solve equations with fractions, it's always easiest to multiply the whole equation, both sides, by the least common denominator. Basically, it will clear the fractions and it'll make your life much nicer. That's our goal. To determine the domain, because again, fractions are weird, we need to factor the denominators and determine if there are any values for the variable that would make the denominator equal to 0. Because remember, we can never have a 0 in the denominator of a fraction. If we find one of those, we throw it out. It's not in the domain. So let's look at this first one. When I look at this, I have denominators of 6, 4, and 8. None of those can ever equal 0, so my domain I already know is all real numbers. We like that one. My least common denominator is 24. So what I want to do is multiply each piece of this by 24. So I'm going to multiply this by 24, I'm going to multiply this by 24, and this by 24. So let's take a look at what happens when we do that. 24 and 6 can reduce. 24 and 6 cancel to make 4, and 4 times x is just 4x. That's my first term there. 4 and the 24 reduce, making this guy here a 6. So I end up with minus, there's a minus sign there, right? Minus 6 times x minus 3. Then here, the 8 and the 24 cancel, leaving a 3, so this side ends up being 3 times x plus 1. Now I'm going to go through and distribute, so I end up with 4x minus 6x, and remember the minus sign also goes here, so I get plus 18 equals 3x plus 3. Combine like terms. Here I get negative 2x plus 18 equals 3x plus 3. I'm going to add my 2x over here to make this 5x. Subtract the 3 over here to make this 15. So I get 3 is the value of x. There's that. So I want you guys now to try this problem. Again, we're going to have a domain of all real numbers to begin with. All right, now let's look at something that's a little bit more complicated. This guy, I look at the bottom and I can see I've got an a minus 1 and a 1 minus a. Well, a minus 1 equals 0 when a equals 1, and 1 minus a equals 0 also when a equals 1. So my domain is that a cannot equal 1. Everything else is good, but a cannot equal 1. My least common denominator, well, I'm looking at this and I see a minus 1 and 1 minus a are remarkably similar. If I were to multiply this by a negative, that would become a minus 1. So that's actually what I'm going to do first. I'm going to do 3a minus 5 over a minus 1, and then I'm going to change this to a plus sign. That's where that negative is going to go. So this becomes 2a over a minus 1 is equal to 2. Now, my least common denominator here is the value a minus 1. It happens to be in both of those. So I'm going to multiply everything in this equation by a minus 1. Now, the nice thing is, on the left-hand side of the equation, the a minus 1s will cancel with both of those. So we are just left with, right here, 3a minus 5 plus, again, the a minus 1 would cancel with the a minus 1, so I've got 2a equals, however, over here, nothing cancels, so it'd be 2 times a minus 1. So I get, over on this side, 3a and 2a is 5a. I have the minus 5 is equal to, distribute, 2a minus 2. So I get 3a is equal to positive 3, so a equals 1. However, pause. I got a could be 1, but up here it tells me a cannot be 1. So because that solution gets thrown out, we have no solution to this problem because it contradicts the domain, or we could use that symbol. All right, let's take a look now at this guy. I want y'all to do this one. It works just like the one I just did, very similar. So look at that m minus 3 and the 3 minus m and ask yourself, how are you going to change that to make your life easier? We'll go over it in class. All right, let's look at this next example then. Now we've got x over x minus 2 plus 2 over x plus 3 equals 10 over x squared plus x plus 6. Remember, my first step is always to factor anything that can be factored. That's kind of a theme through everything in rational functions. Well, my first two pieces can't factor, so they just chill. Plus 2 over x plus 3 is equal to, the 10 can't factor, but this here can. I want two, it's an AC method, two numbers that multiply to -6, add to +1, would be x plus 3 and x minus 2. Well, you look over here, we've got an x minus 2 and an x plus 3. So my domain means that x cannot equal, well, if I made x -3, then this would be 0. And if I had made x +2, ooh, hello, come back, then this other piece would be 0. So my domain is x cannot be -3 or -2. And my least common denominator is going to be x plus 3 times x minus 2. So now we're going to multiply each piece of our equation by x plus 3 times x minus 2. So when I do that, I'm going to multiply this side by x plus 3 times x minus 2. Over here, it's going to multiply by x plus 3 times x minus 2. And same thing here, we're going to multiply times x plus 3 times x minus 2. And what we're going to find is that some things are going to cancel. The x minus 2's cancel over here, leaving just x times x plus 3. And here, the x plus 3 and the x plus 3 cancels, leaving just plus 2 times x minus 2. And on the other side of the equation, the x plus 3's cancel, the x minus 2's cancel. I'm left with just 10. So now we're going to distribute, as always. So I get x squared plus 3x plus 2 times x is 2x, 2 times -2 is -4, equals 10. Since I have a squared term, I want to get everything on the same side of the equation because it's going to be quadratic. So I get x squared, 3x and 2x is plus 5x, -4 minus 10 is -14, equals 0. Then I need to factor this. Two numbers that multiply to -14 and add to +5. I like x plus 7 times x minus 2 equals 0. So now we set each factor equal to 0. X plus 7 equals 0. X minus 2 equals 0. So x equals -7, 2. Except when we look back up here, we can't have a 2, so the 2 goes away. So my answer is just x equals -7. All right, and I want you guys now, or we're going to do this one in class together, so just be ready for that. If you want to attempt it, be my guest. Otherwise, that's where we're going to start next class. So, thank you all so much.